working on the exam 1 review, which covers chapters 12 and 13. Let's start with question number 1. It's a conceptual question. It's asking for finding the correct statement about solutions. A says that solvent is a mixture the solvent in a mixture of gases is generally considered to be substance in greater amount. You know, like in any type of solution, whether a gas or solid or solution, liquid, you have the greater amount as the solvent. And in a mixture of gases, you remember the example I gave you was the air. So in air, solvent is, which gas is more abundant in the air? Nitrogen. And the solutes, you have more than one solute. It's going to be oxygen. We need oxygen, but it's not more abundant. So don't mix it with nitrogen. Oxygen, carbon dioxide, carbon monoxide, methane, and many other gases. Question number 2, and again another conceptual question. So it shows that you should expect some conceptual questions in your exam 1. How does the solubility of a gas in a solvent depend on pressure and temperature? Solubility on the gas in a solvent. So I would say in a constant temperature, I bring the example of a can of Coke or Pepsi. In a constant temperature, by increasing the pressure, solubility increases. What law do you use? Henry's law. S is KH times P. By increasing the pressure at a constant temperature, solubility increases. So increase the pressure on a can of Coke, you can dissolve some more carbon dioxide in it. Alright, the first 2 questions, we said they are conceptual, so let's start some questions which are more on the calculation side. Question number 3. Question number 3 is a relation between the concentration units for a solution. What is the mass of H2SO4, sulfuric acid, in a 38.2 centimeter cube, and right now we know centimeter cube is the same milliliter. In a 38.2 centimeter cube sample of concentrated sulfuric acid that has a density of 1.84 grams per centimeter cube and consists of 98.3% sulfuric acid. So what you do here is that you need to find mass. What is the mass of H2SO? What is the mass of H2SO4? So why don't you multiply 38.2 milliliter by the density, so you will have, it will give you the gram. But what is the grams of solution? This is centimeter cube of solution. So this is solution. This is 1.84 grams of solution per milliliter of solution. So you can cancel milliliter of solution from milliliter of solution, and the answer is going to be 70.28 grams of solution. Okay? Now, based on what is given, 98.3% means 98.3 grams of H2SO4 in 100 grams of solution. That's the meaning of 98.3%. So now you have 70.28 grams of solution and you need to multiply it by what you have, 98.3 grams of H2SO4 divided by 100 grams of solution, because your goal is to find the grams of H2SO4, and the answer is going to be 69.1 grams of H2SO4. Again, as I mentioned in the video, the lectures, you need to find out what you are solving for and then build it based on your unknown. That was question number 3. Question number 4. Again, another concentration of solution question. A concentrated sodium hydroxide solution is 50.5% NaOH by mass, means 50.5 grams of NaOH in 100 grams of solution. That's the meaning of 50.5% by mass, and has a density of 1.53 grams per milliliter at 25 degrees Celsius. We're supposed to find the molarity of NaOH. Now you should know that molarity is moles per liter. Each time you have molarity, if you're confused, open it to moles per liter so you will know what to build. So you're supposed to build this this molarity, moles per liter. So what you would do is that 50.5 grams that you have, you multiply it by the density, 1.53 grams of, these are for solution, right? Per milliliter of solution. It's an abbreviated form of solution. So grams of solution with grams of solution will be canceled. You will have grams of NaOH over milliliters. What do you need for the molarity? Moles per liter. So go ahead and use the molar mass of NaOH. 1 mole of NaOH is what? Almost 40 grams. But let's go with the accurate one. 39.91 grams of NaOH, so you can cancel it. Now you have moles. You just need to change your milliliter to liter. 1 liter is 10 to the 3rd milliliter. And at the end, you will have 19.3 molar. So again, you need to know what you're building. Moles per liter. So try to change the top part, the top of the fraction to the moles. You have grams. You just need to use the molar mass to change the mass to mole. And then for the grams of solution, you need to change it to liter. Each time you need to change the mass to volume, you need to use the density, because that's the only unit that has both mass and volume in it. And then based on the unit you have for your unknown, you convert from milliliter to liter. I hope it was clear. Let's move towards question number 5. Question number 5. What is the percentage of Na2CO3 by mass? Percentage by mass in a 1.92 molal, lowercase m, of an aqueous solution. Means the solvent is water. So 1.92 molal means what? Moles of Na2CO3 by a kilogram of water, correct? That's the meaning of molality, molal. Now, you need to change this kilogram to gram, because at the end you need the mass in grams. So 1 kilogram is 10 to the 3rd grams, and go ahead and use 1 mole of Na2CO3, use its molar mass of 2 sodium atoms plus 1 carbon plus 3 oxygens. Then you will have 106.01 grams of Na2CO3. So you have grams over grams, and at the end you need to multiply by 100 because that's the percentage, right? So you will end up having 20.4%. I see in the answer key you have B, but I worked on it so many times that apparently D is correct, not B. So if you got the same answer, don't be surprised. I hope I haven't made any mistake. Question number 6. Question number 6 is, how many moles of urea, the molar mass is 60 grams per mole, must be dissolved in 66.6 grams of water to give a 2.4 molar solution? So we need a 2.4 molar solution, and we have 66.6 grams of water. How many moles? What was the molality? Is moles per kilogram of solvent, which is water here, right? So molality is given 2.4. Go ahead and change this to kilogram divided by 1,000, so it will give you 0.0666, correct? Oops. 0.0666 kilograms of water. 0.0666 kilograms of water. So how many moles? It will give you 0.15 moles of urea. It's pretty easy. Question number 7. What is the molality of a solution prepared by dissolving 9.08 grams of urea in 93.8 grams of water? So you have 9.01 grams of urea. In the previous question, it gave you the molar mass, or you can calculate it from the given formula. So 1 mole of urea, it's almost 60 grams, right? And then for molality, we need the moles. So we already built the moles, molality. Moles per kilogram of solvent, right? And then you have 9.0 in 93.8 grams. 93.8 grams is 0.938 kilograms. Don't forget, you need to change grams to kilograms because you need it for molality. And it will give you how many molar? I got 1.59 from calculator, which is almost 1.60 molar. That matches what you have in the answer key. Question number 8. We have space for question number 8. What is the mole fraction of water? Mole fraction is shown in X of water in a solution that contains 0.8 moles of ethanol and 1.6 moles of water. So how do you find the mole fraction of water? By number of moles of water. Do divided by total moles of water. So go ahead, how many moles of water did you have? 1.6. And then you have 8 plus 1.6 in this solution. So the mole fraction is going to be 0.17. That was question number 8. Let's move towards some questions about colligative properties. Question number 9. Question number 9 is asking for the freezing point of a 0.19 molal solution of glucose in water. Delta TF is KFM, and KF is given as KF is 1.858 degrees Celsius per mole, and molality is 0.19 mole, which delta TF would be 0.35. But the question is not asking for freezing point change. It's asking for the freezing point itself, so it's going to be 0.00 because it's the normal freezing point of water, minus 0.35 because by dissolving some ethanol, the freezing point lowers. So it would be, instead of 0, it would be minus 0.35 degrees Celsius. Question, it was question number 9. Question number 10 is asking for what is the boiling point change. It's asking for delta TB, which is KBM, of a solution containing 0.723 moles of naphthalene in 250 grams of liquid benzene. So KB is given as 2.53 degrees Celsius per mole times, let's build the molality. The molality is 0.723 moles per, don't forget to change the grams to kilograms, 0.250 kilograms. So it will be 7.32 degrees Celsius. That's the change in the boiling point. 11. Seems like we are done with the questions of chapter 12. This is a question about chapter 13. The oxidation of ammonia produces nitrogen and water via the following reaction. So let's write the reaction because we need the equation to solve our problem. 4NH3 plus 3O2, 2 and 2 plus 6H2O. And this is question number 11 again. We are supposed to find from the rate of formation of H2O, rate of formation of H2O. Which is 3 moles per liter second. We are supposed to find the correct statement. If you do this procedure that I give you, try it for all of these 5 choices, you will see A is correct. How? You know that H2O is a product, right? So 1, and it's produced. So 1 over 6, the inverse of the coefficient. 1 over 6 times 3, right, must be minus 1 over 3, no, this is for ammonia. Rate of, or delta T, delta NH3, that's the rate, right? Over delta T. So if you want to find the delta NH3 over delta T, you just multiply 4 times 3 divided by 6, which is 2. So it would be 2 moles per liter second. So you see A is correct. You can do the same thing for the rest of the components involved in this reaction. Question number 12. The reaction of ammonia ion with nitrous acid. In this reaction, the net reaction is given. If the initial concentration of nitrous acid is 1 molar and after 17.8 seconds has elapsed, the concentration of nitrous acid has fallen to 0.72 molar, what is the average rate of reaction? So when we want the average rate, we just go by delta concentrations divided by delta T, which would be 0.72 molar minus 0. molar divided by 17.8, which gives you minus 0.15 molar per second. The rate decreases, the average rate decreases. That was question number 12. Question number 13. For a reaction, for a certain first order reaction with the general form of A gives the products. The rate is 0.32 molar per second when the concentration of the reactant is 0.27 molar. What is the rate constant for this reaction? It's not asking for anything else. It's not the integrated rate law. So you just write down the rate law for a first order reaction. The rate is given is 0.32 molar per second. And you are going to find K, rate constant, times 0.27 molar. So K is, when you divide them by each other, it would be 1.1 per second. All right, let's move to the short answer for question number 14. It's very short and easy. Only from the rate law, find out the reaction order. Question number 14. The rate is given as K NO squared times H2. And we're looking for the reaction order with respect to nitrous oxide. Reaction order for nitrous oxide. This is the exponent, which is the 2. Question number 15. The reaction given is first order in H2. Let's write down the equation because we need to write down the rate law from the equation. 2H2 plus 2NO, 2H2O plus N2. This reaction is first order. Let's first write down the rate law. It's K. It's based on the reactants, but it's not based on the coefficients, right? It's H2. So the question says it's first order in H2, so we don't write anything because we don't write 1. And it is second order in NO, means we need to put. So you see, again, the reaction order is not necessarily the coefficients. All right. A little bit more calculation for this question 16, number 16, initial rate method. There is a data table given. I'm not going to draw it. It takes some time. We are supposed to find the overall order of their reaction. So if we write the rate law as A to the power of m and B to the power of n, we are supposed to find m plus n. Okay? So let's find out what is m, what is n. For finding m, we need to keep the concentration, pick the two experiments, then reach the concentration of B is constant. And for finding n, we need to keep the concentration of A constant. So let's, you can go either way. Let's find m first. Rate of experiment 1 over rate of experiment 3 over 1 is going to give you m. So its rate of 3 is k x A3. The beep is my old school watch. All right. Right, I'm writing the rate law for each of these experiments. So now you can cancel k and k and plug in. Rate for the third experiment is 15. For the first one is 5. For A concentration you have 0.6, and for experiment 1 you have 0.2 m, and for B, both of them is 0.1. So you can cancel them. Then m is going to be 3 equals to 3 to the m, so m is obviously 1. In order to find n, you can relate experiment 2 to 1. So again, the same drill. So rate of the second experiment to the first one is 20 to 5, and then you have the same concentration for A, which you can cancel, but for B you have 0.2 to 0.1, and the exponent is the same, so you just use n. Then 4 is 2 to the n would be 2, so m plus n is 3, which matches what you have. All right, another initial rate method, a little bit different. That's when you have more than 2 reactants. So it's not harder, it's just longer. So for 17, question is given you the data table. I'm not gonna draw it again, but the following data were obtained in a kinetics study of the hypothetical reaction A plus B plus C gives you the products. Using the initial rate method, what is the order of reaction with respect